All right, folks. Can I ask you guys to stop talking, please? Today is the review day, so we're going to start with just kind of talking about test format, and we're going to do some specific review stuff because there's some stuff from the quiz that I definitely think we need to talk about. And then after 40 minutes or so, I'm going to leave you and let you work on the review on your own. Deal? All right. So students should be able to, given a picture of a chi-squared distribution, level of significance, and the chi-squared calculator for that level of significance, be able to describe what the chi-squared critical value means, be able to indicate what part of the distribution corresponds to level of significance, determine if we should accept or reject the null hypothesis given a chi-squared calculated value, and then if your conclusion is wrong, determine the type of error. You should be able to conduct and analyze a t-test. The parts are write the null and alternative hypothesis while defining variables if you're going to do that symbolically. Use the calculator to find the critical number and p-value. Given a level of significance, make a conclusion. And if your conclusion was wrong, determine the type of error. You should be able to conduct and analyze a chi-squared goodness of fit test. Write the null and alternative hypotheses. State and verify both conditions. Use the calculator to find degrees of freedom, a chi-squared calculated value, and p-value. And given a level of significance or chi-squared should be critical, make a conclusion. And lastly, you should be able to conduct and analyze a chi-squared independence test. You should be able to write a null and alternative hypotheses, compute expected counts, verify the large counts condition, use the calculator to find degrees of freedom, chi-squared calculated, and p-value. And then given a level of significance or chi-squared critical value, make a conclusion. Does everybody feel okay with what I'm asking you to be able to do? Yeah. Okay, what's going to be the hardest part? For you, maybe. It's going to be telling the difference between reading the story problem and going, is that a t-test? Is it a two-variable t-test? Is it a chi-squared independence test? Is it a chi-squared goodness of fit test? Because I will not tell you in the problem what type of test you're doing. Brooks.
Chi-squared is when there's two variables and you're finding the difference.
There's two variable t-tests also.
Oh, okay. So what's the difference between those two?
Yeah, that's what we want to work on today. Okay, so I am going to just pull some problems from the review, and we're going to kind of work through some of this stuff together. The emphasis I'm going to place is on knowing which type of test is going on and how to write the hypotheses. Everybody okay? Sure. I'm not going to worry so much about doing the computation on your calculator. Is that fair? Is that okay? Looking at the test and quiz results, especially, or the last quiz result, by far the biggest problem was not having your hypothesis correctly, so then they didn't go into the calculator correctly, so it didn't get the right answers, and it was like a cascading problem. Okay? All right. We're going to skip number 1 because it tells you what type of test to do. Right? It says a chi-square test was carried out. Let's read number 2. says 4 parties contested an election held 2 years ago. Conservatives captured 29% of the vote. Liberals 41% of the vote, while the Greens and extreme right parties split the rest amongst themselves equally. A survey of 1,500 voters this year yielded the following: 410 conservatives, 590 liberals, 270 Greens, and 230 went to the extreme right party. Has the voter support changed since the elections? Test at a 10% level of significance. What type of test should we be doing? Anthony, I'm going to skip you because you've been in AP Stats before and probably are amongst the most comfortable doing this in the room. I'm going to default away from the Anthony's and Lucas's here that have done AP Stats. Has anyone else done AP Stats in this room? Okay. I know you two have though, right?
Yeah.
Okay, so I'm not going to call on you today. That doesn't mean that I don't go to call on you ever again, but just for today. Colby.
This is a guess.
Mhm.
2 samples.
That's incorrect. Nicole. It's not a t-test. Quinn. It's a goodness of fit test. How do you know? What in this told you it was a goodness of fit test, Quinn?
Percentage, and then it gives you the actual numbers because you're trying to find just the expected amount.
So it told you a known distribution, right? And you're wanting to test new observed values against that old known distribution, right? You're trying to see if the new survey fit the old known values. That would be what I would do here. The percentages. That's the known distribution. Right? And then you have this survey data that we want to calculate or compare to the known distribution. So how would I calculate my expected counts? Actually, before we do that, how would I write my null and alternative hypothesis? Who can tell me what the null hypothesis should be for a chi-squared goodness of fit test? Kevin. Okay, so you could say the observed counts are a good fit to the known distribution or to the expected counts. That would be fine. I would encourage you to use the phrase good fit. And the alternative then is that they are not a good fit. Okay? Be specific though. Don't say they. Say what they are. The observed counts is not a good fit to the known distribution. Right? That's what you're testing to see if the new stuff fits to the old. Brooks.
So if they're in percentages, but then the other list is in just numbers, how do you do that?
So the numbers are the observed counts, right?
Yeah.
How am I going to get an expected count?
Oh.
So if the observed counts match the known distribution, how many conservatives would I have expected to have? 0.29 times 1,500. I would expect 29% of the voters that I surveyed to report being conservative.
Was there 1,500 the first year?
Doesn't matter. There's 1,500 sampled now. So I'd expect still 29% of them to be conservative, right? That would be my expected count. Is everybody okay with that? And I would do the same thing then right? How would I find the liberals?
100 times.
Good, 41% of 1,500, so 0.41 times 1,500. How about the greens? How would I calculate the expected counts for the greens? Well, the observed count for greens is 270. How do I calculate the expected, though? So how many, with 29 are liberals, 41 are, 29 are conservative, 41 are liberal, and then the greens and extreme right split the rest of the percentage amongst themselves equally.
So you do
How much is left?
100 minus 29 plus 41.
Alex has got it, 15% for greens and extreme rights. Everybody agree? Okay, so I do 0.15 times 1,500 for each of those. Everybody okay? On how we did the expected counts there?
You do 0.15 times 1,500 divided by 270.
Nope. Nothing with the 270.
What does this look like in the top?
What it look like in my calculator? Two lists. L1 is the observed counts, L2 is the expected counts.
Which test?
Goodness of fit. Yep. Bless you.
You just do 0.15 times 1,500 and that's it.
Yeah, that'll give you the expected count. The probability of it happening times the number of times it's going to, the number of attempts you get.
You don't have to do it for all of them, do that?
I did do it for all of them. We just talked through how to do it for the conservatives, liberals, greens, and far right.
Yeah, but you said you don't do anything with the 270.
Those are the observed counts. So Colby, you're going to have two lists, right? You have the observed that was given to you in the problem, and then the expecteds, which now we have to calculate. Which we just talked about verbally how we're going to do that, right? So this is L1, that's L2, and then I do my goodness of fit test in my calculator. Is that what you needed?
Yeah.
Uh-huh. Jamie? Sure. All right, has anybody grinded this through on their calculator yet to tell us what the result is? Anybody got a p-value for us?
You can just enter in your calculator as like that, right? They don't need to 359 times.
You can type that into L2 and it'll just do it for you. Yep. Yeah, you can type in like an operation into L2 and it'll just do the little calculation. You don't have to type it into the main screen and then like write it down and copy it in manually.
Then like liberals need to like connect the liberals and conservatives need to be in their own row, and then like the other party needs to be their own row, but they all got to do it.
They got to line up, yeah. I'm going to start getting the next question in here.
What's the degree of freedom for us to put in?
How do you calculate degrees of freedom?
It's total minus 1.
It's the number of categories for your variable minus 1. How many categories are in our variable? What's our variable? There's political affiliation as our variable. There are 4 categories. So the degrees of freedom is 3. What's up? Oh, okay.
I put in like the last one.
What did it give you?
5.7.
I suspect you made a typo into your list.
Wait, what? You got that for
I got
I got
0.0096.
0.0096.
I got 7 times 10 to negative 4.
Again, probably a typo in your list then.
Oh, I see what I did.
Oh, I got it.
So again, as long as your degrees of freedom are correct and your list is correct, there's no way to get the wrong answer here. So if you're getting an answer that doesn't make a lot of sense, you probably just type something into your calculator wrong. Like if you're entering data in, what should your final step be before you go ahead and execute the test?
Check it.
Double check your inputs, right? Make sure that you got the right thing in the right spot, that the numbers are copied in correctly, you didn't forget a 0 at the end of something. Nicole?
Why'd your answer be right since there's the zeros in
I mean, I just wrote down
Yeah.
close enough, right? You should have 3 sig figs, though, yes. Brooks? Yeah. Alrighty, next one. It has been estimated that employee absenteeism costs U.S. companies more than $100 billion per year. To understand the trend of absenteeism amongst its employees, a large corporation recorded the weekday during which individuals in a random sample of 724 absences were away over the past 6 months, as shown in the table. Do these data suggest that absenteeism is higher on some days of the week than on others? Test at a 10% level of significance. So take a minute, think about it. The 4 options, right? T-test, 2-sample T-test, goodness of fit, chi-squared independence. So read it again if you're not sure. Okay, what test is it certainly not? Oh, that is the answer, what it is. Okay, what the 2 it can certainly not be is independence. Why can't it be independence? There's not 2 variables, right? The only variable is the day of the week. Can't be a 2-variable t-test because there's not 2 variables. So you're between t-test and goodness of fit test. Everybody's okay with how I was able to 50-50 it at least? That's helpful, right? You can make every question a 50-50 which test is it question. That's probably helpful. This is a goodness of fit though. Why is it goodness of fit?
Because you were given the first variable to need to test if they're accurate in the second variable.
What's the known standard though? Yeah. So is absenteeism equal across the day of the week? That's what it's asking. What's the probability, the expected, okay, the known probability for Monday? What is the known probability that we're absent on Monday? 1/5. Tuesday, 1/5. Wednesday, 1/5. Thursday, Friday. That's our known distribution, that they're equally likely. The null hypothesis then is that the observed absences are a good fit to the known distribution of absences, which is equally likely. The alternative is that they're not a good fit. Again, don't say they, be specific, but we're talking, so I'm going to say they. How would I calculate so these are the observed. How would I calculate the expected?
All those times sound good.
Yeah, or 724 divided by 5 all the way through, right? Thank you, Quinn. 144.8 is the expected count for all 5 of them. And then you just grind that thing out on your calculator. How do I know this isn't a t-test? Right? We said it was down between a t-test and a goodness of fit test. So if you wanted, it's not independence. If you wanted to do this as a t-test, you'd have to do it for each day of the week separately, right? You have to do a t-test for Monday, a t-test for Tuesday, for Wednesday, for Thursday, for Friday, because the question is asking specifically if it's higher on any day of the week, right? Does that make sense? Would you want to do 5 separate t-tests? No. How about just one goodness of fit test to see if equally likely fits the data? That's how I knew it was a chi-squared goodness of fit rather than a t-test. So a t-test can compare one category of a variable to one category of a variable, but to compare an entire variable against the known standard, that's a goodness of fit test. Yes, Brooks.
We're never going to use z-test. It's only...
Z-test is not something we do in this class.
All right.
Yep. Sure. So when you grind this through, what are we going to get? Our p-value should be 0.230 or 0.230. If you're grinding that out, that's what you should get. How many degrees of freedom should we have? 4 is correct. Okay, I'm going to start popping in the next. Do you guys feel like this is helpful?
Yeah.
Right? Like, part of it is you got to read enough of these when you don't know what it's going to be to get a feel for it. What also told us in the problem there's 724. Yeah. You could add them all up too. Because it asks in the question, is absenteeism higher on some days of the week than the others? If it wasn't, what would that mean? It's equal on every day, right? That's the expected then, is that absenteeism is just random and that it's equally likely on one day versus another. Now, what would you expect? It's not. What days do you think are more likely to be absent? Or 3-day weekends, right?
You said, like,
that would be my expectation as well.
It was all by random. That's why you took the average of all the absences and made that the expected.
The expected is that if it's random, then you have a 1 in 5 chance of being absent any day, right?
Okay.
So just 1/5 across the board. It tells us in the problem that there were that many, right? So you could have added them all up. You got 724 also, but it told us in the problem. All right. We ready to do another one? Okay? This one says, many restaurants use a device that allows credit card users to pay with their credit card at the table. The device also allows the users to specify an amount for a waiter tip. In an experiment to see how it works, a random sample of credit card users was drawn. Some paid with the device and some paid in cash. The percentage left as a tip was recorded and listed below. Can we infer that users of the device leave larger tips? Test at a 10% level of significance. Read it again. Okay, before you start trying to tell me what test we're going to do. That's my first question, though. So I just want to give everybody a chance to read it again and think about it for a minute before we start talking. I have 2 people ready to volunteer, which is great. I love that. I just want to give everybody a chance to read it and think about it first before we start talking. All right, what can't it be? Can't be either chi-squared test, right? Why? Well, there's no known distribution to compare against, so it can't be a goodness of fit, and there's really just one variable, right? Cash or device. Yeah. Everybody agree? So it is a type of t-test. Which one? 2 sample. Good. Does it matter that the sample sizes are different? No, man. Okay. Because you have data for 2 different categories. There's 2 samples. There's a sample from data or from cash and a sample from device. Right? That makes sense. It's not 2 variable, it's 2 sample. There's 1 variable, but there's 2 like pools of data. Now, how would I write the hypotheses? Yes. In a t-test, the null hypothesis is always they're the same. The alternative is, great, how'd you decide device is greater than cash? That's what you're trying to prove. So is this a 1 tail, 2 tail, left or right? Nope. It's 1 tail. And now left or right's going to depend on which one you call the null, right? Which one is mu naught? Does it matter? No. You'll get the same answer, but if you make cash mu naught, it'll be left tail. If you make device mu naught, it'll be right tail. So it just, you gotta make sure your inequality is going the correct way based on which one you name it.
Actually, data point for device, is that what there's one for cash? We still add that.
Oh yeah. Does it matter that they have different sample sizes? Nope. The calculator will handle it. Anthony. Well, is it 2 tail is not equal to 1 tail is a greater or less than? So the way I've written it, this is a Now remember, when you go to the t-test, remember there's two options for inputs, right? What are the two options on a t-test? Well, there's data or stats, right? Which one are we doing here? No, data. Because are we given means and standard deviations? No. What are we given? Data. Hence, we want to do the data option for our two-sample t-test. Emerson.
We do two sample t-tests, not like based off the pool, but based off of the action.
Correct. And is our t-test pooled?
Yeah.
Yes. How do I know? It's always going to be pooled. Brooks.
SX means standard deviation, right?
Correct.
Okay. And if your P is less than the level of significance, you reject it.
Yes. You guys ready for one more? Do you guys feel any better about doing this? Emerson, still what? You don't even have to come anywhere. You're in my CT. All right. Now, if you look at this, immediately you should know what? Look at what test?
No, chi-squared.
This is absolutely some kind of t-test. Whether it's one sample or two sample, I have to read, but I know it's a t-test. How do I know it's a t-test?
Oh, because you're given standard D.
I'm given means and standard deviations, right? I will not be given that. I will not be given that otherwise, right? I have to be doing some kind of a t-test if I have means and standard deviations. Everybody's okay? All right, let's read. A psychologist examined whether the content of a TV show influenced the ability of viewers to recall brand names of items featured in commercials. The researchers randomly assigned volunteers to watch one of two programs, each containing the same 9 commercials. One of the programs had violent content, and the other had neutral content. After the show ended, the subjects were asked to recall the brands of products that were advertised. Results are listed below. Do these results indicate the viewer memory for commercials may differ depending on the program content? Test at a 10% level of significance. Okay, what type of t-test is this? This is two sample. That's correct. How do you know? You're testing if two things are different, right? Rather than like, I had one thing, and is it the same as the other thing? Right? Like a one sample t-test will be like, hey, I was making light bulbs this way, and now I'm making them this way. Is the new way better than the old way? That's like a one sampler. Here, we're testing one against the other. How do I write my null and alternative hypotheses? And the alternative is? They are different. How do I write that? Good. So is that one tail or two tail? Two tail, because it's not equal to. Everybody feel okay?
Zero.
We did errors on the quiz.
Do we have to answer details like that?
I don't know. I'm just talking about it.
Yeah.
I mean, was it listed on the thing? I think maybe for the first part, right? No, that was a chi-squared. Doesn't look like it. So I pulled these specific example problems from the review. Why did I do this? And these are the ones that didn't tell you what to do, right? All the other ones told you the test to do. So I just pulled the ones where it's like, what are you doing here? How do you know? What did I read in here that told me what to do? Make sure you go back and practice that. That's going to be the dividing line between like doing well and not doing well. If you can't pick out what type of test to do, you know, it's hard. Yeah.
In this case, you would reject a null, right? So then like the memory of person is probably different.
Yeah, that there is an effect there on the memory.
Yes, I did. I know you have something.
Yeah.
I'll literally show you right now.
Okay,
I still do better. I don't need
All right. Is everybody okay?
Well, in that worksheet that we got last class,
The activity you're talking about? The one that we said we're supposed to do in class?
I was telling to Miami.
Okay. Yeah, did you finish and put it in the folder? Okay, so you should finish that and put it in the folder then. The data for the activity is in the OneNote if you need it. Yep. I'm going to stop talking and stop the recording now for you guys. You should work on your review. Everybody's okay? My suggestion for you guys in terms of studying. Yeah, number one, review, but shh. If you haven't actually done the homework, like you just looked in the back of the book and wrote down the stuff from the back of the book, maybe try doing the homework for this one. I'm just putting that out there as something to try. I think that a homework is kind of helpful here to get a feel for like what a t-test sounds like, a 2-sample, a 1-sample, a chi-squared, a goodness of fit, an independence. If you didn't actually do those homework assignments, I would encourage you to make sure that you go back and try some of them. Particularly if you feel like I don't have a good handle on this particular type of test. Everybody good? That's my suggestion. Not to say that anybody's just been copying the answers to the homework out of the back of the book. You would never do that. But if you were, this would have been a particularly bad chapter to do that on, because I think that you really have to read the questions and think about them and like work through all the details. And if you do that, I think everything's going to go a whole lot better than if you didn't. Okay? All right, I'm done. You guys have 4